Hey, what's going on, guys? Let's do this problem right here. The question is asking an insulated rigid tank is divided into two equal parts by a partition. Initially, one part contains 4 kg of an ideal gas at 800 kilopascal and 50 degrees Celsius, and the other part is evacuated. The partition is now removed, and the gas expands into the entire tank. Determine the final temperature and the pressure in the tank. Let's see how we can find this one. So first of all, let's look at the internal energy. So since we don't have any heat in or heat out or any work out, because we don't have any boundary work, right? Because this is a fixed part and there's no work done by the system or done to the system. So the delta U is going to be 0, right? The key word is insulated rigid tank. This shows us Q also 0 and delta U is 0 from this one. So we know that delta, so here they are asking for the temperature. We can write delta U as mCv delta T, right? That's also 0 because delta U is equal to 0, mCv delta T also 0. So we can expand this one as mCv T2 minus T1 is equal to 0. Therefore, mCv T2 is equal to mCv T1. I just expanded like mCv T2 minus mCv T1 is equal to 0. Then we move this part to the other side. That gives us this value, like this equation. And if you notice that mass is not going to change, so there's nothing to change the mass. So we can, both of the mass are equal, we can cancel both of them. And CV is going to be same because CV doesn't change due to the volume, right? So CV also cancels. So from this one we can prove that T2 is equal to T1. So the temperature is going to be same. So here the temperature T2 is equal to T1, therefore T2 also equal to 50 degrees Celsius. So that's the first question asking, determine the final temperature. And let's see how we can find the pressure. So here we are going to use ideal gas law. So P1, V1, let's look at the initial condition. P1, V1 is equal to nR T1 and P2, V2 is equal to nR T2. And we know that temperature is equal in both of them because we proved that already, right? T2 and T1 are equal, so this N and R is going to be same. So since N and R are same, this is equal to this one. So we can equate both of them. P1 V1 is equal to P2 V2. Now the question is asking to find the P2. P2 is equal to P1 V1 over V2, right? V2. And they are saying, initially they are saying that this is divided into two equal parts. So if this is V1, this is also V1, right? So the total volume is going to be 2V1. So that's going to be the final volume because VF is going to be when they are removing this one. They are saying the partition is now removed and the gas expanded into the entire tank. So the V final is going to be 2V1. So that's going to be the final volume. So from this one we can, instead of V2 we can write 2V1. P1 V1 over 2V1. So V1 cancels. So the pressure is going to be P1 divided by 2. So P1 is 800 kilopascal divided by 2. That's going to give us 400 kilopascal. And that's how we do this kind of problems. I hope you guys found this video helpful. See you next time.